Here's a quick tutorial on how to do a dihybrid cross. So here you see a dihybrid type of problem. So it's going to give you information, so you really need to pay attention to what the information that's given so that then you can create the proper genotypes of the parents. So the problem says, if a curly hair, capital H, is dominant to straight hair, and freckles, capital F, is dominant to no freckles, what is the probability of having a curly-haired, freckled child if a woman who is homozygous for curly hair and freckles marries a man heterozygous for curly hair and has no freckles? So the first step is going to be writing the genotypes of the two parents. So you really want to pay attention to the information. So I like to underline it. So homozygous for curly hair and freckles. So this would be the woman or mom. Okay, she's homozygous for curly, and we said capital H is for curly hair, and homozygous means same. So that's for the curly hair part. And then with dihybrids, remember, this is a two-trait cross. So it also says homozygous for freckles. Okay, so that's a woman. So then we have the man. Okay, I'm going to underline it again. Heterozygous for curly hair, no freckles. So heterozygous for curly hair. Heterozygous, again, means different. So that means one capital H, one lowercase h. And then no freckles is recessive, therefore it has to have two lowercase f's. So I like to make my lowercase f's with like a little tail just so you can see the capital versus the lowercase. So that's step one, finding the genotypes of the parents. Now I'm going to show you what the next steps would be if you're going to do the long way. If it's a dihybrid and you're doing the long way, that would be using the 16-box Punnett square. So what you're going to do next, so step two, is you need to find the 4 different gametes for each parent. So to do that, you're going to FOIL the 4 different alleles. Now you're going to put 1 and 3 together, 1 and 4 together, 2 and 3, 2 and 4. It's almost like giving each allele a dance partner. So I've written the genotypes of both the woman and the man down here below. So remember, that was from the previous page or previous part of the presentation. So what I'm going to do is I'm going to put numbers underneath the 4 gametes. So 1, 2, 3, 4. Okay. So what I'm going to do is I'm going to put 1 and 3 together. So that's going to be capital H, capital F. Then I'm going to put 1 and 4 together. Capital H, capital F. Then I'm going to put 2 and 3 together. Capital H, capital F. And then I'm going to put 2 and 4 together. So capital H, capital F. Notice how this woman has the same 2 letters for the gametes. So all our gametes are the same. Now I'm going to do the same thing with the man. 1, 2, 3, 4. So I'm going to put 1 and 3 together. So that's going to be capital H, lowercase f. Then I'm going to put 1 and 4 together. Capital H, lowercase f. Then 2 and 3 are going to go together. Lowercase h, lowercase f. And then the same thing, 2 and 4. So I'm just going to write real, like here. Okay, I'm running out of room here, sorry. All right, so notice he has 2 different of the letters for the gametes. Now, step 3 is you're going to place the gametes for each parent that you just found by foiling on the Punnett square. So remember, this is the long way. So you're using a 16-box Punnett square. So I'm going to put mom on 1. So I'll put her on the top. Remember, it doesn't matter if you do mom or dad. Remember, all her gametes were the same. Now I'm going to put dad's gametes on the side, and I'm going to write it in a different color so that eventually when we start filling it in, you can see which alleles come from which parent. So there you go. So that's step 3, placing the gametes on. Now step 4 is then going to start filling in the Punnett square. Okay, so step 4 is to fill in the Punnett square. So we have the 2 parents' gametes at the top. So remember, in red was mom, so that would be the egg, and then in green would be representing the sperm. So when they come together in fertilization, that is then what the child would have. So you always want to fill in the Punnett square with the same trait first. So because we have H's first representing whether it's curly or straight hair, I'm going to keep that theme and I'm going to keep writing the H's first. Now you want to show the law of dominance still. So you always want to write capitals before lowercases. So I'm going to bring down the H, bring over the other H. So remember, I put it in 2 different colors so that you could see which one's coming from mom, which one's coming from dad. Then I'm going to bring down the F, and I put the capital F first to show the law of dominance. And then I'm going to bring over the lowercase f. Okay, so that would be the first parent. So then I just do the same thing across. So again, I'm going to bring down the capital H, bring over the other capital H, bring down the capital F, and bring over the lowercase f. And then I continue to do that. So in this case, the top row have all the same genotype. That isn't always the case. So then I'm just going to continue doing this all the way through. Now, when you guys are doing this, you don't have to use 2 different colors. I was just trying to show you which allele was coming from which parent. But again, notice how I'm writing capitals before the lowercase to show the law of dominance. When I do this, you guys could always fast forward the video. So what I like to do before moving on is I just want to make sure that I wrote everything correctly. I made sure like I put the capitals where the capitals are supposed to be, and then I made my lowercase, because if you mess one of these up, the whole thing then is going to be wrong. Now remember, this is the long way how to do it. So step 5 will be interpreting your Punnett square results. So that means you're going to have to find your genotypic ratio, phenotypic ratio, and then any type of probability question that it's going to ask you. So the first thing I would do is I would start from the top left box and I would write down that genotype, and then I would count how many there are. So in this case, if we start with big H, big F, little f, there's 1, 2, 3, 4, 5, 6, 7, 8 of those. And I literally would write it down just like this. So then I choose the next genotype. So it's big H, big F, little f. So I'm going to count up how many of those there are. 1, 2, 3, 4, 5, 6, 7, 8. And I write it down like this. So if we're looking at the genotypic ratio, it would be 8 to 8. And I literally would write 8 big H, big F, little f's to 8 big H, big F, little f's. So that's the genotypic ratio. Now you need to find the phenotype or phenotypic ratio. So what does this look like? So we have big H. So you have to go back to the beginning of the problem. So remember, big H stands for curly, which is dominant to straight, and then freckles, big F, is dominant to no freckles. So with that information, these children that have big H, big F, little f genotypes, they're going to have curly hair and they're going to have freckles. All right, so then we're going to look at the other genotype. Big H, big F, little f. Well, they're heterozygous for both. So because they have one capital H, that means they have curly hair, and because they have one capital F, that means they have freckles. So they have curly hair and freckles. So we kind of lucked out on this problem. It's not always this like nice and easy. So that means you would have 16 curly and freckles. So curly hair, freckles, to 0 straight. So I'm just going to abbreviate it. And no freckles. So then the last thing we have to interpret is we got to do the probability, because that's what the problem was asking us. It says, what is the probability of having a curly-haired, freckled child? So what we can do is we can use our phenotypic ratio. So curly-haired and freckles, we said there were 16s out of 16. So that means it would be 100%. So if these two parents had a child, it would be 100%, or 16 out of 16, that they would have curly hair and freckles. Okay, so now what I'm going to do is I'm going to show you guys how to do it the shortcut way. So step 1 is still the same. You read the problem, read what's given, and then you find the genotypes for both parents. So here's step 2 if we're doing it the shortcut way. Step 2, you're going to set up monohybrid cross for each trait separately. So that means I'm going to set up one monohybrid cross, remember that's a 4-box Punnett square, for the curly hair, or the trait would be type of hair, so curly or straight, versus whether or not it has freckles. So I'm going to put mom and dad on first. I'm going to use the same color this time. So big H, and then big H, little h. Okay, so then I'm going to bring that trait together. So remember, I'm going to put dominant, so the capital before lowercase to show dominance. So in this way, you don't need a foil to find the different gametes. So I'm going to do the same thing, but I'm going to put this trait in a different color. I'm going to bring them together. Okay, so that's step 2. So now I need to interpret these. So I'm going to look at the H's first. So the curly hair, straight hair. So if you look at it, you're going to have 2 capital H's. So I'm just going to write that down here. 2 big H's. And then there's going to be 2 big H, lowercase h's. So I'm going to do the same thing for the freckles part, or no freckles. So if you look at this, we have all 4 of them are big F, little f. Okay, so now what you're going to do is step 3. You have to cross multiply your results. So how I'm going to do that is, see how it says 2 capital H, I'm going to then multiply it with the 4 capital F, lowercase f's. So that would be 4 times 2, that's 8. Capital H, you're just going to then put them together. Big F, lowercase f. Then I'm going to do the same thing with the next genotype. So we have 2 capital H, lowercase h's. So I'm going to cross multiply over here. So again, 4 times 2 is 8. And then I'm going to put the genotypes together. Okay, so again, this would be your genotypic ratio. 8 capital H, capital F, lowercase f, to 8 capital H, lowercase h, capital F, lowercase f. So again, then you would find the phenotypic ratio. Well, you guys know capital H is for curly hair, and then we have freckles. So again, that would be 16 curly-haired freckles to 0. And then if you wanted the probability, again, it would be 100% that the child was curly-haired and freckled. Okay, so this way, it's a lot quicker to do. It's just not as easy if you're not really good with math. So you guys can choose which way you want to use for doing a dihybrid cross. So go ahead if you rather do the long way. Go ahead. If you want to do it the shortcut way, try that way. If you want to do your homework in both ways, try that out. If you guys need any help, please feel free to email me.